Hi there. My name is Kerrie Lalli, and I am from Walter G. Byers School in Charlotte, North Carolina. And I'm here today to share with you some of the things that we do here at our school to connect our aquaponics system to the next generation science standards with our K-5 students. So to kick it off here, I just wanted to share with this picture. This is a photo of some of our first and second graders. They're at our school waiting in line to get their breakfast, and our aquaponics system is right in our cafeteria. So as the kids are entering school for the day, this is what they get to experience and be part of. So every single day they are part of this, engaging activity first thing in the morning where they're looking at the fish, they're observing the fish, they're feeding the fish right before breakfast, so their school day hasn't really even started and they're already learning just while waiting in line for breakfast. And this is a typical day. I mean, we have kids piling up to get to see the fish in the morning. Pretty cool. So just to give you a quick introduction, if you're not familiar with the next generation science standards, they're science content standards that cover kindergarten all the way through 12th grade. And they were developed to be research-based and also incorporate skills that will get our kids ready for careers in the 21st century. So you'll see embedded throughout these standards a whole lot of technology, a lot of real-world application of skills. It's no longer just a list of facts that kids need to learn. It gets split up into the 3 dimensions of scientific learning, okay? We have the cross-cutting concepts, and these are things that help students relate one domain of science to another so that they can see that life science is connected to physical science, and physical science has an impact on earth science, and earth science can be used to help us with engineering problems and back and forth all around. We have the science and engineering practices as part of the 3 dimensions of science learning, and that specifically talks about what scientists and engineers do in order to do their job, in order to solve problems, in order to design things, build systems, that sort of thing. And then there are the disciplinary core ideas, which is what we probably think of as our science standards. That's more of our traditional, the content that you learn in each grade level. And it is 4 domains: life science, physical science, earth and space science, and engineering, which is pretty cool. That's actually one of the content domains that the kids learn now in school through NGSS at least. So thinking about our aquaponics and thinking about K-12, where we really get our bang for our buck, if you will, focusing our instruction, is those cross-cutting concepts. There are definitely content standards in NGSS that go along with every grade level. But if we're talking about holistically on a school level, how our instruction with aquaponics really makes an impact, it's through digging into these cross-cutting concepts. So I've shared with you on the screen, let me hide myself for a minute, those 7 cross-cutting concepts that are part of NGSS. Patterns, identifying patterns, using patterns as evidence, and then by the time we're in third through fifth grade, being able to predict changes based on patterns, which kind of leads us into the next one, cause and effect. Looking for causal relationships and then not only identifying them, but testing them out. So we're not just spitting back facts about cause and effect, we're actually digging into how cause and effect works in the real world. Scale, proportion, and quantity. This is all of our measurement. Standard units of measurement starting in kindergarten, where they're using rulers to measure length and going on, building on it every year to get more and more complex. Systems and system models. So this is where we take a system and we find the components of that system that are integral parts of that system. Without it would not work. And then we look at how those components are connected to each other. And as you're going to see, this is huge in our aquaponics system. Energy and matter. So interestingly enough, our energy and matter cross-cutting concepts for elementary school at least really focus on conservation of matter. which is a very difficult concept when you're looking at this in, say, 5th grade science. But when we start young with our kindergartners, we're really just looking for cycles. We're looking for how things move and change through a cycle without anything disappearing or without anything else being added in. Structure and function. This is kind of like the bread and butter of science, I feel a lot of times, because the structure of materials or organs or whatever we're talking about really does help dictate the function. And we get into that starting in kindergarten through these cross-cutting concepts. And finally, stability and change, which is another one, huge when we're using the aquaponics system to really teach. Measuring changes in terms of differences over a period of time. So not just looking at a daily check, but looking at something over longer periods of time and looking for those patterns and looking for those changes. So I've chosen a few of these to kind of dig deeper into to show some examples of how we hit these cross-cutting concepts in elementary school by teaching using the aquaponics system. So patterns. I kind of started with this one because this one, our youngest kids really, really get into, our kindergartners especially. We identify life cycles using the system. And it's not just necessarily drawing a diagram or, okay, we're going to plant a seed, now the seed turns into a seedling. It's actually getting to do it, right? So in this upper corner, you see, this is a kindergarten example where you see they drew their little piece of rock wool with their seeds in it on day 1. And then the label isn't on the work, I apologize for that, but you can see what this student saw the next day or 2 days later. And then finally what they saw a week later, and you can see they started drawing, well, there's going to be roots down below and there's going to be leaves up top, right? And so here this student is already identifying that there's a cycle to this. Now we have zip over here to a 2nd grade example where this student went all the way. And I love the fact that in order to really study the cycle of the plant, we took one of our lettuce plants out of the system and put it in a bottle that I had, a cut off bottle. And she even added the empty apple juice label on there. So very scientific in her approach to labeling her diagram. And in our school, the students are involved in every single aspect that goes on with the system. So they are putting the seed, they're soaking the rock wool, they're putting the seeds in the rock wool, they're plugging those little rock wool plugs into the raft, and then they're transplanting those, as they get larger. And as you'll see later, they finally do, they go all the way through harvest and all that kind of thing. So our students K-8 really, because we're a K-8 school, are involved in every aspect of this process. Okay, systems and system models. This is one of my favorite examples, so much of my favorite example that I made a anchor chart of it for my classroom. Learning the relationships between the fish, the nutrients, the plants, and back again. And I love the fact that this student, I identified it as symbiosis, that both the fish and the lettuce are getting something from it. And this is a flow map that this student drew, where she starts out with fish food and shows that flow of energy through the system. Also including how water gets cleaned, where things are going. I love the fact that she has the sump tank showing that it goes 2 different places. It goes back to the fish tank, but it also helps feed the lettuce, right? And so not only are we learning about the parts of the aquaponics system and how they work together, like the actual engineering of the system, but they're learning about the relationship between the living things that are involved. Matter and energy. This is a great one for conservation of mass, or conservation of matter, I should say. And this example that you see in the photos, check out that basil leaf. We had basil that went bananas last year. It grew so big, like we couldn't figure out, I mean, it was getting so much nutrients, it was just growing crazy. But tracking the flow of energy through the aquaponics system, just like the student had drawn in that previous diagram that we saw, but also looking at the feeding rates and how more food for the fish means more nutrients for the plants, means more growth for the plants, maybe, right? Because we do get to that limit where it's not helping anymore. So this is a great example of how we can track matter and energy through a system. And of course, I had to include a picture of our cute fish. That's rainbow fish, by the way. That one has a name. So the students are understanding this, and we talk about some data collection in this portion of our cross-cutting concepts. We look at how much food we're giving them. Did they get too much food? Did someone give them a snack as they walk through the cafeteria that day? That sort of thing. We track all of that, how much food they're getting, and then we can look at relationships between the food that went in and the plants that come out. Stability and change. We take lots of observations of these plants, tracking their growth. You see a student right there. She is actually getting ready to measure the roots on that lettuce as we harvest it. We have plants, for some reason, we grow roots for days. Something is pretty cool about our system, that our roots get really big and really juicy. You can see that we keep a data notebook in the center there. Some of it, yes, I write for them because the kids are doing the actual testing with the testing kit that we have, but I sometimes record for them just to make sure we get it written down accurately. Decimals are hard. But they're comparing the growth rates of different plants that we've tried in the system, different types of lettuce that we've tried. They're doing water chemistry testing, yes, in elementary school. You'll see the picture in the lower right. They're actually weighing out the iron supplement that we're going to put in the system. So, and that's something, once again, at breakfast in the morning, that's a great time for me to use that time for extra instructional time. And they do a lot of this work after they're done eating their breakfast. It also motivates them to finish. But they're learning how to use a balance. They're learning how to pair a balance. They're learning all these side skills that aren't necessarily explicitly taught in their classes, but they're learning how to do it, which is going to be huge for them later in life. Those 21st century skills. So in conclusion, there's one of our very first harvests that you see down there over on the right side, left side of the screen, I'm sorry. And that's only half of what we were able to harvest the very first time we did this. And those are some very, very proud fifth graders in that picture. They were then sent around the building to teachers across the grade levels to offer them fresh lettuce. So our very first harvest we shared with the staff here, kind of as a thank you for their support of what we were doing and letting me borrow their students out of class from time to time. And then after this, we actually partnered with a nonprofit organization called The Bulb that does pay what you can farmers markets in the Charlotte area. So a lot of the lettuce that we were growing that was excess, more than we could have ourselves, because of course we've had to taste this with and without dressing, by the way. We've donated and helped the community that way too. So if you're interested in following our journey through aquaponics in our K-8 school, you see there on the screen My STEM Lab's Twitter and Instagram and our school's Facebook page. And if you have any questions at all about what we do or just want to reach out and collaborate, I would be happy to do that with you. There's my email address on the screen. Thank you so much for having me, and and I look forward to hearing some of the other sessions.